Today we're having a look at the UNI-T UDP3305S. So this is a programmable linear power supply which comes with a traceable certificate of accuracy and certification. This unit will run you about 720 Canadian dollars, 519 American dollars, and this specific unit was sent to me for review by UNI-T, but no money has exchanged hands. UNI-T calls this a 4-channel unit, but I think I would call it a 3-channel unit. It has 2 main channels, 1, 2, that do 0 to 30 volts, 0 to 5 amps. It has a 3rd channel, which does 0 to 6 volts, 0 to 3 amps. So those are fine. But channel 4 is this USB port, which is 5 volts, 2 amps. And this is more intended to charge your phone or, power boards or something like that. So I would say this is a 3-channel power supply with a bonus USB. Just my opinion. The neat thing is you can adjust the voltage and the current down to the milliamp or the millivolt. It has serializing and parallelizing the channels 1 and 2 built into the unit, so you actually don't have to, link this one to this one or whatever. It's done all internally, and it is also programmable. So let's take a quick look here to start with. First of all, the power button is a physical ka-chunk button, which I really love. None of that, soft on, off stuff. And look at the boot up time. It's ready to go. So that is pretty cool. You see the main display here has your 3 channels, channel 1, 2, and 3, very easily accessible. Then to set voltage and current, you just hit this button here, voltage, let's say 12 volts, enter, you're set to 12 volts. Your current, let's say 0.5, enter, and there you go, you're ready to go. What's really cool on top of that is channel 3 has a couple of preset voltages, 1.8 volts, 2.5, 3.3, and 5 volts that are just scrollable like this, so you can just quickly choose the voltage you want. These are pretty common voltages, especially if you work with Arduino, and microcontrollers. 5 volts, 3.3, pretty common. And then 2.5, the halfway point, and 1.8. So that's for newer logic circuits. Turning on and off the channels, super easy as well. You get a visual indicator behind the button. And a really cool feature is that if you have multiple rails connected to multiple things on your circuit, and you want to power them all up at the same time, you can hit all on or all off. It just turns on or off. Another cool thing is these little indicator lights. They show you when you're in constant voltage or constant current mode. We're going to explore those a little bit later on, but I think it's really cool that you get a visual indication of what's going on with your power supply. Don't forget, this is a very large unit. This is 14 inches deep, and so this is made to be up on a shelf somewhere while you work on your workbench. This is where this is going after, up there. So having these visual LEDs to be able to see things at a glance is very useful. On top of that, if you're only working with one channel, or you have one channel that's more important than the other ones, you can hit this zoom function and you can see the values right here in big. So not only do you have the LED visual indicator here, you've got the big screen to show you the values, and you've got your constant voltage, constant current light down there. I think that's really well thought out. My setup for checking the accuracy of this power supply is not quite the way you should do it in a professional setting, but they didn't send it to a professional setting, they sent it to me. So what I have is a couple of the multimeters I love the most, which is the Kaiweets HT118A and the Fluke 179. This one's sent to me by Kaiweets, this one's sent to me by a viewer. I also have this OWON XDM 1041. This is my go-to multimeter when I can't find these because it's always bolted to my bench up there. And I have these all set up in parallel, so we'll be able to compare the readings of all of these with this one here. Now, why don't I use a more accurate multimeter? Well, that's because I don't have a more accurate multimeter in my setup yet, until we take a look at the UNI-T UT8805E that was sent to me for review. So stay tuned for that. We're going to have more digits and more accuracy on top of that when I review that multimeter. But for now, averaging out all these numbers should get us in the ballpark of the accuracy figure. Now, UNI-T claims on the voltage range it's underneath 0.03% plus 10 millivolts, and on the current underneath 0.2% plus 5 milliamps. So we should be able to see if it at least respects that because I think 10 millivolts is a lot of millivolts, so I don't think we're going to see that much deflection. By the way, the total output for this thing is 328 watts. That's if you turn all the channels on at their max. I already have 1.5 volts in here, so let's turn it on and see what happens. So the display reads 1.502 volts, and we can tune that up or down using this rotary dial, but I'm not going to bother. I'm just going to set it to a certain voltage and let it go. And don't forget, all of these tests are done unloaded. The 10 meg ohm internal resistors in these parallel together is not enough to pull any real current, so don't worry about that. So as you can see, 1.502 is pretty much exactly what the Kaiwitz is saying. The Fluke is reading 1 millivolt lower, and the XDM 1041 is reading 12 millivolts lower. Let's go up a little bit. Voltage. Let's go 2.5. Oops, maximum. I think I missed a period there. So 2.5. There we go. So here we go. Kaiwitz is showing 2.502, 2.500 on the Fluke, and the O1 is showing 2.4970, and the display here is 2.5. Almost exactly, plus or minus 1 millivolt. So it's looking really good so far. Here we go. We're going to hit the voltage, go up to 5. Look how fast it is to change the voltage on this. It's great. So 6 millivolts over there, 1 to 2 millivolts over there, 10 to 12 millivolts under here, and 3 millivolts over there. Let's go voltage, 15 volts. So we got 15.01, 15.01, 14.980. I'm starting to conclude that this O1 reads low in general. And then we've got 15.07 on the display here. Again, unloaded. Let's go up to the maximum single channel voltage, 30 volts. And here we go. 30.03, 30.01, 30.012. Interesting, the 12 millivolts. This display might be outside of their rated spec. However, the display has a different specification, if I remember correctly, than the actual output voltage. And we've got 29.960 on the O1. So now we can't go any further, right? Wrong. If you just hit the series button, you get a completely different display here. So you see now it's in series. We just have to move this cable over to the series connection over here. And everything is done internally. So now all we have to do is set a new voltage. So voltage, let's go 50 volts, and then turn on the output and see both lights turn on because it's a series output. And we got 50.003 there, 50.04 there, 50.01 there, and 49.922 on the O1. Now you see how those extra digits really do matter? Just you wait till we check out the UNI-T multimeter. It's going to be impressive. And then let's go up to 60 volts. That's the maximum output you can get from this power supply. And here we go. 60.05, 60.01, and 59.91. This is just up in the range where we're missing that last digit. In fact, I think we could push this a little further because it has a voltage limit of 66. So let's try that. Let's just see if it'll work for us. And it does, so there we go. 66.0, 66.0, 65.9, and we got 66.006. So I would say that this thing is pretty darn accurate, at least for the girl I go out with. So that works perfectly for me. When I am better set up to check true accuracy, I will give that a run too. To test the current capabilities of the UDP3305S, I've got here my little power supply testing load, which I built. Link in the description if you want to see the video for that one. And so this one here is the 24 volt version. So I have the voltage set to 28 volts, which is, you know, these things should be tolerant to 14 volts a pop. So 28 volts, and we got a 1 amp current limit. So let's turn on the output. And so at the moment, we've got the current limit at 1 amp, and I'll just go, you can see the 1 is highlighted here, and I'll just roll this up 2 amps, 3 amps, 4 amps. Here it goes. So we're at 43 watts now at 11 volts. Now you'll see the voltage climb up, and that has nothing to do with the power supply. It's just that these bulbs increase their resistance as they warm up. So that's totally normal. and then 5 amps, and that is our channel limit. So we can't go above the 5 amps that we need to power these things and get them to light super bright to their max. So what are we going to do? Well, that's actually pretty simple. You just hit this parallel button, and now this channel comes in parallel with channel 2. And then here we got our 28 volts. Let's just do a little bit of current limit here. We're going to start back up at 5 amps. And I'm going to move to highlight little 5. I'm going to turn this on. And here we go. This is back where we started. And now we can roll up the current. There's 6 amps. Now this is going to be swamped a little bit, so I'm going to move this off camera. So now we've got 144 watts, but we are hitting 24 volts. We're almost there. I'm going to go up another amp. So here we go. So now we got an amp limit of 7 amps, but we hit our 28 volts, so we are steady now at 6.5 amps. But that is only with one of these devices. We can try to pull the full 10 amps if we plug another one in. So let's do that. Alright, got them both set up now, and I completely forgot to use the zoom to show you. So there we go. There's the 5 amp limit, and I'm highlighted little 5, so I'll get to move it up. And then I'm going to turn this on. There we go. So at 5 amps, they're going to slowly glow. You can see that. But let's crank it up. 6, 7, 8, 9, and 10 amps. And so there you can see our max voltage is 17 because we're in constant current mode with the little red LED lit up there. Actually, it works for both channels, which is pretty neat. And we can actually crank the current up just a little bit to 10.4 amps. That's our max here. 3, 4. There we go. So we're pulling a total of 200 watts out of this channel. Now, if we had a load that can go up to 30 volts, then you get the 300 watts out of this. But so far, this is the best sort of load that I can come up with to test these power supplies. But as you can see, it is pulling out the 10 amps on a single parallel channel, no problem. Don't forget, we still have some current we could pull from channel 3 if we really wanted to. Another cool feature about having this giant display here is that there's a waveform button, and you can actually see the historical waveform. So let's say you have a device that pulls intermittent current. Well, you'll be able to see that here. And on top of that, you get your voltage, your current, and your power, and it shows all 3 of the channels at the same time as well in different colors. So this is really easy to resolve. And on top of that, if you switch your channel, you switch which one is shown here on the side. So you get a lot of information at a quick glance. Decided to do a quick current accuracy check here while my load is connected. So I have the XDM 1041. It has the most amount of counts, and that's why I want to use it. And this is set to a current limit of 5 amps. So let's see what that gives. Turn it on. And that shows 5.001, and here we have 4.9968. But if you remember, it's a little bit, it did read a little bit low on the voltage measurements. So I think this is pretty damn close. So let's start rolling down the current and see what we get. So let's go 4.5, and there, pretty much 4.5. Looks like the same offset here too. And let's go down to 4 amps, so it's 4.001, and you got 3.9970, and let's roll that down all the way down to 2.5. It's looking pretty good, looking a little closer now, but yeah, 2.5 on the dot. And let's drop this down to something really low, like half an amp, and here we go, half an amp on here. Let's see how low we can actually go. So here is 100 milliamps, and this is actually showing 100.5 milliamps. And we'll go even lower. 50 milliamps. Oh, that's pretty damn close. 10 milliamps. Can it read it? Look at that. It's doing a really good job, even though the voltage is tiny. So yeah, clearly, clearly this is pretty good. There we go. We've got, you know, 4 microamps of difference. That's pretty nice. And 1 milliamp. So we got 1.5 milliamps on this one. Pretty much as good as I can test it until I get the 8805 set up. In the rear, really happy, it uses a standard IEC connector with a fused input. It also has selectable voltages, which is nice. When it came delivered, it was actually selected to the correct voltage for here in Canada, which was good. Has RS-232, standard for pretty much all test gear, but also has these digital I/O ports, which are for the programmable nature of this device. It has a LAN port because there is software you can use to control this thing over your network. And there's 2 USB ports because one is a USB device and one is a USB host. So that's pretty interesting that this works as a host or as a device. Also has a cooling fan, which is quite quiet until you load the snot out of it, and then it starts making a little bit of noise. But honestly, it's very quiet compared to a lot of test gear that I've seen before, and certainly more quiet than the AC to DC power supply I use to power my read-ins. So this thing shouldn't be a problem even in quiet environments. And on the top, you've got the carrying handle, and they're putting a lot of faith into these 2 screws to hold this bulk up. However, so far so good. Seems very solid to me. And make sure you've got a darn good shelf because this thing is heavy and it's 14 inches deep. So you need a lot of space for this thing, but I think it's worth it. This power supply also has a ton of stuff which is beyond the purview of this first look video. For example, if I click this list delayer button, you can program in a whole bunch of situations where you can control the volts, the maximum voltage, the maximum current, and for how long. And you can have this, you know, up to 2047 points of trial things, and you can make it output for however many cycles you want. So if you have a device that needs to survive fluctuating voltages, like let's say an automotive application or even an off-grid application, you can test your device to, you know, to as much as you want in that. And also you have storage here, and we'll talk about this in a moment because there's an onboard recorder. So if I go to utility here, there is a monitor function that I believe can set up, you set up the condition here, and it can output to those digital IOs in the back, which is pretty neat. Also, there is trigger, where you can have this for input, I believe, where you can toggle the output or input depending on what you're sending to this thing. So someone who is at least mildly versed in Arduino, for example, can do remote control of this device, which is very neat as well. Here's the recorder, which can record the waveform. I believe it outputs a CSV table, and it saves it, you know, to the drive storage. And I believe you can move the storage, you know, on and off the USB or access it with the USB on the back, which is also very neat. And then of course you have your setup here. I've turned the beeper off because I prefer the beeper to be off, and I've turned the brightness of the screen way up because I love a very bright screen, and this thing has the ability to go bright, which is very nice. These things though, they take a little bit of know-how to set up. The user manual is actually quite complete, but it is huge. So these are things that I'm going to learn and use in my everyday usage, and then talk about them during the full review. If you guys have something you want to see specifically during the full review to make sure that this unit is right for you, let me know in the comments below or what you'd like to see in the full review. And so that's it for this first look of the UNI-T UDP3305S. This thing has exceeded my expectations. This is way more than my skill level would require as far as a power supply. However, the price range is right. So at about $520 US, the amount of programmability and accuracy and channels and the fact that it's a linear supply from a reputable vendor with a traceable certificate, this thing is just incredible value. If you need a programmable power supply for what you're doing, at least consider the UDP3305S, because it seems like a fantastic unit, built like a brick dunny, and it seems ready to meet your needs. Make sure you're subscribed to the channel, because UNI-T sent me quite a bit more test gear to take a look at, and I'll be going through them sequentially. And as I add them to my workflow, you'll see that the testing methods will change and will include them, and that'll also mean that it'll trickle into my regular video making, increasing the overall quality around here. So thanks again to UNI-T for sending me this thing for review. I can't wait to use this all the time. And for those of you watching, thanks for being here.